Hello, welcome to our Trusted Substrate panel discussion. I'm Bill Fletcher from Linaro, and I'd like to introduce our panelists. We have Christian Graber, Project Director Digital Business at Bosch Rexroth. We have our own Francois Ozog, Director of Linaro's Edge and Fog Computing Group. We have Eustace Asenganwa, Principal Program Manager, Azure Internet of Things, Microsoft. We have Peter Robinson, Principal IoT Architect at Red Hat. And we have Loic Paladé, Software Architect from ST Microelectronics. Welcome to the panel. I'd like to ask Francois to give a very quick intro to Trusted Substrate, what it is, and why it's needed before we go to our panel session. Francois.
Hello, thank you for being there. We have a panel today because we have a problem. And the problem is mix and patch. People would like to mix and match a board with an operating system, but BSPs prevent that. Actually, BSPs have been nicely defined at FOSDEM this February. It was said that a BSP is a badly patched fork of an ancient U-boot, a badly patched fork of an ancient Linux, and a badly patched fork of an ancient Yocto. That was often a prehistoric compiler. So to mix and match, you need clear and clean interfaces between firmware components and between the firmware and the OS. That's what we've been working on over the past 2 years with ARM and the Linaro members, and the result is the Trusted Substrate. You heard a number of people, like Matteo Carlini, talking about trustedfirmware.org advances. Trusted Substrate builds on those projects and more. So Trusted Substrate is a collection of firmware components that implements EFI interfaces and that can make your system ready compatible. It comes in 2 flavors, one based on EDK2, one based on U-boot, which supports both 64 and 32-bit. You heard it well. We have a UFI secure boot on a 32-bit platform that allows a single OS binary image to boot on a number of boards. By the way, let me stress that we're really talking about EFI interfaces. There is no intention to bring software architecture or EDK2 code style into U-boot, for example. This is really about interfaces. Another perspective to this is that U-root community for Linux boot is actually building a Go implementation of the EFI interface. So it's really to stress that we're really talking about interface and not code. In essence, we also can think that the Trusted Substrate is like building a tool chain that's carefully assembling the right set of components at the right set of version with the right set of parameters. And last but not least, Trusted Substrate ambition is to simplify building business value on top of the ARM Trust Zone. So I hope I've covered most of it. And Bill, I guess we can start the discussion.
Okay, thanks, Francois. So I guess I'd like to kick off a first question, maybe with some of the business context. And so maybe I'd like to direct to Eustace. What do you think needs to happen, Eustace, in order to bring trusted computing on this firmware foundation to the masses?
Thank you, Bill. That is a very good question. A one that I think should wake us up in the brave new world that we live in now. So to really appreciate what I think Trusted Substrate can bring to us, let's review where we've been, recently, the world of IoT, where hyperconnectivity has heightened our awareness to issues pertaining to security and privacy. A world where we continually distribute intelligent compute from cloud to edge, where real value is at stake, and a world where time to market is defined in months, not years anymore, like we traditionally used to, and a world where many are demanding secure devices in order to achieve comfort in IoT. So these are just some characteristics, and what we are observing is new behavior from these characteristics. So for example, many solution providers, many people building IoT solutions, when they acquire devices, they don't just acquire the device and take ownership of it. More and more, we're seeing a trend where they are demanding that the OEMs, they don't sell the devices, they should provide the devices with support, usually for 10 years or 15 years or 20 years of patches, again, highlighting the awareness in security. And when this happens, for the OEMs, it becomes a challenge to them. How do I support a device for 10 years and 15 years when I'm consuming BSP components, where it is only supported for 2 years and with very infrequent patching? So that becomes a very big challenge, for the OEMs and what we see more and more of them do, responding to this challenge, is to reduce their SoC portfolio. So if they used to be providing a product portfolio that has 10 different SoC, they're reducing those to maybe 5 or 4 so that they can manage this kind of a burden. And that becomes a roadblock, that becomes a challenge for IoT to proliferate. And this challenge becomes even heightened when we start thinking about about confidential computing, as Francois mentioned earlier with Trust Zone. So confidential computing takes the problems at an even higher level because the complexity of the devices are higher and it becomes very difficult. And I mean, I can count the OEMs that are building devices in this regime in maybe one finger, like less than 10 in the world. So what is really happening here, what we are observing here is the burden on the OEMs of building devices. And the challenge to support it long-term becomes very big. And the logical solution to this is to distribute that burden, is to share that burden amongst many so that it doesn't become, just the burden of the OEM. And in that sense, I see the Trusted Substrate project, as Francois described, as being that one area where we can all contribute into. So instead of the OEM picking the components of the BSP and build custom BSP for different boards or different devices, would it be possible, for everybody to contribute into a common project? At least that is where I think and I see a Trusted Substrate going. So chip manufacturers, they contribute into this project. Looking forward to the Trusted Substrate, the governance of it. They should make it in such a way that you contribute it in such a way that you don't have to build DSPs anymore, as Francois described earlier, where everybody can just take from it. Now, when it comes to trusted computing, there is Open SDK, Open Enclave SDK, which is from the CCC, the Confidential Computing Consortium. The point I want to bring here is that projects like that do not manifest in devices. You need a project where you bring all of those components where an OEM can pick up and then implement inside of a device. So how do I see Trusted Substrate in the business world? I think it is a very important project in that it helps us share the burden of building the substrate into a device. And what that allows us to do is to assure that devices that are being built into this brave new world are secure devices. If we leave the responsibility to individual companies, it becomes too much that they end up building unsecure devices and end up having deployments based on unsecure devices, hence not secured. So I think Trusted Substrate has a very great potential in helping all of us, everybody, realize the dream of IoT by sharing the burden of complexity. That's what I think on the business side.
Thanks, Eustace. Does anybody else on the panel want to pitch in either on points Eustace has raised or the scaling issue generally? No. Okay. So I'd like to pitch a question to Christian with respect to the challenges maybe that you face in your industry, specifically relating to something that Eustace said about updates and the 10-year lifetime. And what challenges do you see with regards to the lifetime of components for you?
Thanks for asking. I think Eustace has brought up some very important questions here, and we have challenges which are similar to that. And I mean, I'm representing Bosch Rexroth, and we are supplier for construction machinery, like excavators and such. And in that business, typically we are talking about lifetimes of 15, 20 years, as you said, as just mentioned, or François has mentioned. And on the other hand side, we have very fast cycles when it comes to cellular technology, for example. So you have this challenge on the one hand side, a very long lifetime for the machine, but a very short lifetime for the technology. And everybody is expecting, I mean, every year a new smartphone, and the same is also expected from your connectivity devices on such a machine. And for that, we need to close the gap, how to bring updates, not only on a software side, but also on a hardware side, on these machines. And on the same at the same time, also being able to keep the software as stable as possible, because you cannot afford just to have a completely redesign of your software architecture just because you change from 4G to 5G, for example. From that point of view, it's really important to have standardized interfaces which you can rely on and which you can take over from one device to the other, from one chip to the other. And this is quite important for us. Even though right now we see for connectivity that, I mean, also for those machines, you talk about second life, third life, and we don't expect that in a second or third life of those machines, all the owners would extend a subscription for connectivity or something like that. So maybe connectivity would just live for, let's say, 5 to 6 years today, but I assume that this is going to change in the future.
Okay. Well, thanks, Christian. Anybody else want to jump in on any of those points? Otherwise, I'll pitch a question to Loic. So down at the component level, what do you see from ST's point of view as benefit for better definition in the integration between firmware components? What does that bring to you?
Thanks, Bill. It's indeed an important point for ST. As you know, on each SoC platform, we have specific boot sequence, and so we have specific firmware versions to support our SoC, and so to be able to start Linux kernel and associated applications. Firmwares can be based on open source project, of course, like is done on STM32MP1 platform, but also on the proprietary solutions developed by SoC vendors. Anyway, they are different, and when you are integrating all together different open source projects, they are independent. They have their own open source governance and their own life cycles. So it's up to the SoC vendors to select the right versions and to make complicated integrations of all the software components all together. That's part of the burden we just discussed just before. The work done in large group for the previous 2 years, and also in the different ARM initiatives like EBBR group, has defined some good use cases and features that are required by customers to develop their product on the SoC. Either some edge product, IoT product, but it has been extended to automotive and industrial product also. And this use case and features has allowed to define some role and responsibility between all the different software components and to define some clear APIs between them. And that helps integrations of all the components all together and guarantee compliance between them. We can see that in large group, development are not only at kernel levels, but in TFA, U-boot, Opti, kernels, and all development are aligned, delivered all together. It's not some standalone features now, but it's transversal features. And that is key for ST as SoC vendors to be able to provide a complete integrated solutions. Moreover, now with the unique, I would say, API defined by eBBR and with a RFI interface, we have a clear contract, I would say, between the firmwares, so all the boot stage, and the distributions. And thanks to this API, it is a part of the distributions on any SoC. So that means that as ST, we can provide reference distributions, including the trusted substrate for the boot and the security part of our platforms, compliant with the different contracts. And it will be easy for customers to change the distributions and buy the one you want as soon as the distribution is compliant with this contract. Of course, to do that, there is an important point is that stock vendors should upstream support in kernel of its SoC to be supported by the distributions. Else, you need a special build for your own SoC, and you are not in the generic distribution image. So I would say thanks to this, the good integration of the firmware, we extend the capabilities for customers to select the development environment you want on our platform.
Okay, thanks, Loic. If anyone wants to jump into that, they're welcome. Otherwise, I think I would put Peter on the spot and ask him about standardization, potentially OTA, and the opportunity to say something about Rail for Edge and what it looks at from the underlying platform.
Yeah, so from a Red Hat point of view, standardization around firmware and boot paths and security is critical. Speaking with customers, they don't want to have to implement, different custom platforms for every different type of edge device they're going to have to use out there. In some cases, we've got customers with hundreds or even thousands of use cases, and with all the different devices they're going to need to support, they want, a single operating system, a single platform, a single process. They don't want to have to spin up, a different team to manage and maintain every single device out there. They want to have, a single team managing a single platform that can, implement huge amounts of diverse use cases. It's very hard to secure lots of different platforms, and security on the edge is even harder because you don't have the physical security of a data center with four walls and an access control list. And so things like standard ways of being able to do firmware updates to deal with so many of the different security attacks we're seeing now, and like a lot of the recent firmware around a lot of the new different row hammer attacks require firmware in conjunction with operating system updates to mitigate these attacks. And so being able to do over-the-air firmware updates without user interaction, to quote one customer, every time something goes wrong, we don't want to roll a truck to fix it. That customer had devices in the field that sometimes can be hundreds of kilometer round trip just to get to the device attached to a pump somewhere. And having to roll a truck to fix that costs an order of magnitude more than the device itself. And so having, a single process with a single update path is, for firmware, whether it be the device firmware, modem firmware, Wi-Fi firmware, any of the devices, being able to update it in a unified way with the ability to do A/B updates on that firmware. So if things go wrong, it can be rolled back, and you, again, don't need to roll a truck to fix the device, is critical. And so having standards around this, UEFI, the various BSA specs, is critical from a Red Hat point of view. We're not going to implement 100 different ways to update firmware. We're not going to implement, dozens of different ways to onboard device for each of the major vendors. Like, open standards, open interfaces is the only way to deal with this, especially in the edge use case. A number of devices that I've looked at and assessed for customers, you sort of go download the latest firmware, and you have to have a special tool to apply it, and you have to plug in via USB or something like that. And I say to the vendor, it's like, what are you thinking here? This is an edge specific device, and customers are going to deploy tens of thousands of these or even tens of millions of these. Do you expect them to go out and plug in a keyboard and say yes and interact with this every single one of these devices when they want an update? No, that's not going to happen. It's like, my recommendation to the customer is to go and find another device, and the vendor suddenly like, but, and it's like, look, playing with this in the lab is fine, but think about scale. Think about, if a customer has 10,000 of these devices out in the field that are actively being attacked, they want to be able to patch them now, not have to drive around and patch them manually over the next year. Like, it's not viable. So standardized interfaces, standardized processes for dealing with this, hands-off means of dealing with this, so security updates can be applied quickly, is just critical. And Edge and the Internet of Things is exactly that, internet. These devices are going to be connected in weird and wonderful ways, in weird and wonderful locations, and it is no longer a device like an embedded control device of 10, 15 years ago, where it's deployed, never updated, never dealt with, and a lot of these devices are running company IP. They need to be secured. Data needs to be encrypted at rest. Data over the wire needs to be encrypted. And so standards around things like, every device having a TPM, every device having hardware roots of trust and things like this are critical to deal with all of that. And, it's guaranteed these days that, these devices are, it's not if they're going to be compromised, it's when they're going to be compromised, and you need to be able to deal with that.
Okay, thanks, Peter. We're actually coming to the end of the slot, and so I have a question for Reed from ARM, just to give us like maybe a 1-minute thumbnail sketch of the philosophy of Project Cassini that we've heard about today.
Okay, thank you, Bill. Project Cassini was originated or announced back in ARM TechCon in 2019. And really the aim of Project Cassini and the ambition was to galvanize and rally the ecosystem behind three sets of problems or three sets of technology specifications and actual implementations. One of those being system ready, another being platform security architecture, and the third being parsec. Today we're going to focus on or what I'm going to focus my remarks on around system ready and its applicability to Trusted Substrate. But you probably have heard in other sessions in this or other Linaro Connects about the other two. What we're looking at is for system ready to basically create a set of has been created as a set of specifications to enable a harmonized way to support modern operating systems and increase and maximize the portability of workloads across ARM ecosystem devices. For more information on this is all available on the ARM website and developer.arm.com to get full details on it. But specific to Trusted Substrate, we're happy that the Trusted Substrate group has chosen System Ready to be one of the specifications that they actually test Trusted Substrate software against. And so we see Trusted Substrate as a vehicle for scale for Cassini and System Ready.
Awesome. Okay, thanks, Reed. So we're in the dying minutes, unfortunately, even minutes. So I'd call on Francois to maybe make a very brief closing remark and thank us.
You can visit trustedsubstrate.org, trusted-substrate.org or trustedsubstrate.org. You will find many more information, and the next public call will be April 8th. So if you want to discuss all those topics, please join the call. Thank you very much for attending. Thank you for all the panelists for your important insights. So thank you very much to the audience, and enjoy the rest of the show.